Now assume you are having a in order sequence. So this is a in order of a tree. In order is A, B, C and D. Okay. Now let us suppose in exam they have given you an in order and they are asking you to create a tree from this. Okay. So let us see what are the tree possible for this in order. So for this, before, let us see what is in order. In order is left, root and then right. Okay, that means initially you are going to print the left subtree, then you are going to print the root, and then you are going to print the right subtree. So for this above in order, so what are the tree which is possible? So one tree can be something like this: A, B, C, D. So if you see this tree, for this tree, if you try to find out the in order, then you will find out that this in order for this tree is exactly the same, right? Now let us see if there is any another tree possible with this same in order. Okay, so let us suppose we are having this tree A, or make it B, A, and then we are having C and D. Okay. Now if you try to find out the in order for this tree, then you will find out that the in order for this tree is the same, which is A, B, C and D. Okay. So maybe we can have something like D and then C and then B and then A. Now if you try to find out the in order, then the in order for this tree is same, which is A, B, C, D. And let us see if there is any more tree which is possible. We can have D, and then we can have B, and then we can have A, and then we can have C. For this tree also we are getting the same in order. Okay, so there may be a lot of trees which are possible with the same in order, which I'll show you what is the exact number. Now if you say you are having the same pre-order, for example they are giving you in a pre-order and they want you to draw a tree for this, so which is pre-order is A, B, C, D. Okay, so if this is the pre-order, then how many binary trees are possible with this pre-order? Okay, so we can have multiple binary trees. It will be with the same pre-order will be so what is pre-order? It is root, left and right. That means initially you are going to print the root, then you are going to print the left subtree, and then you are going to print the right subtree. Okay, so let us suppose we are having this tree A, B, C, D. For this tree, this we are going to get the pre-order as A, B, C, D. Okay, now let us see if there is any another tree with the same pre-order. It will be A, B, C and D. For this tree we are also going to get the same pre-order. So can we get any other tree which is having the same pre-order? It will be A, and then B, and then we are having C, and then we are having D. For this tree also we are going to get the same pre-order, and so on. We can have multiple pre-orders for a given sequence, right? So in the case of post order also, you are going to get multiple post order with the same sequence. You can try to create the multiple. You can try to create these post orders. Okay. Now the question is, how will you get a binary tree if they are giving you a pre-order or a post order or a in order, right? Now if you see, with the help of only pre-order you cannot get a unique binary tree. With the help of only in order you cannot get only a unique binary tree. With the help of a post order you cannot get a unique binary tree. Okay, now let us try to see if the combination of these can get us a unique tree. Okay, so let us suppose we are having this combination. One is pre-order plus post order. Okay, second combination is pre-order plus in order. Third combination is pre-order, so it is post order plus in order. So if we are having this combination, then you'll find out that with this combination you cannot get a unique binary tree. Okay, but with these combinations you can get a unique binary tree, right? So that means with the help of a pre-order and a post-order you cannot get a unique binary tree. No unique binary tree possible. Maybe no unique binary tree possible. Okay, so maybe for one or two examples, maybe one or two unique binary trees are possible, but in most of the cases there are no unique binary trees. But with the if they have given you a pre-order and a in order, or post-order and a in order, then you can get a unique binary tree. Okay, so this is actually frequently asked question in GATE. So what they do is they give you a pre-order and a in order, or they give you a post-order and a in order, and they ask you if you can create a binary tree with this. Okay, so now let us try a question on this. Now this question was asked in GATE 2007. Okay, and what they are doing is they are giving you a pre-order for a tree. So the pre-order is A, B, D, E, C and F, and they are giving an in order for the tree. So in order is D, B, E, A, F and C, and they are asking you what is the binary tree for this in order and the post order, right? So how do you get the binary tree? If you see this pre-order, so this is actually not post order, it is pre-order. So if you see this pre-order, so in the pre-order initially we are going to print the root, and then we are going to print the left subtree, and then we are going to print the right subtree. In case of in order, initially we are going to print the left subtree, then we are going to print the root, and then we are going to print the right subtree. Okay, so that means in case of pre-order, if you take the first element, so that must be root because it is printing root. So what will happen is this pre-order is going to tell us what is the root. Okay, and this in order is going to tell us what are the nodes in the left subtree and in the right subtree. Okay, so now let us try to draw a diagram for this. So if you see this pre-order, for this pre-order we are having A in the beginning, that means this A is the root. So let us suppose this is the A, which is the root. Now go to this in order and see what are the elements in the left of this A and what are the elements in the right of this A. The elements which are in the left of this A will be in the left subtree for this A. So these elements are D, B, E, and the elements which are in the right of this A, which are F and C. Okay, now we have to see in the left subtree what is the root in this subtree, which is D, B, E, and what is the root in this. So if you go to your pre-order, then the next element is B. That means B is the root for this left subtree. So if B is the root, that means then we go to this in order, and then you see what is the element which is in the left of B and what is the element which is in the right of B. That means if this B is the root, then D is in the left of it and E is in the right of it. Okay, now we are having this FC. So what in this FC, what is the root? We have to answer this question. So go to the pre-order, we have covered all these elements. Now we are having CF. Now in this CF, this C will be acting as the root, and to find out which is the right of it and what is the left of it, we have to go to the in order. So that means here this C is the root. Now go to the in order, and if you'll see that F is in the left of this C, that means F is in the left subtree for this tree. Okay, so that is the unique binary tree for this above pre-order and in order. Okay, now this question is asked in GATE 2004, and what they are saying is they are giving a in order for the tree, and in order is B, C, A, D, and they are giving a pre-order for this tree. So pre-order is A, B, C, D. So it is asked in GATE 2004, and they are asking you what is the binary tree which is possible. What is the unique binary tree actually? What is the binary tree for this given sequence. Okay, so here this is the in order and this is the pre-order. So as we have seen, in case of pre-order is root, left, right, and in case of in order it is left, root, right. Okay, so that means in case of pre-order we are going to, the first element is going to give us what is the root, right, and this in order is going to give us what is the left subtree for this root and what is the right subtree for this root, right. So here in the pre-order we are having A, that means this A is the root. Now if you go to this in order, then in this left of this A we are having BC and in the right of this A we are having D. That means in the left we are going to get BC and in the right we are going to get D. Now go to pre-order and see what is the next element. So the next element is B, right. That means in case of BC, this B is the root, right. Therefore this B is the root and we have to identify is C in the left or is C in the right. So go to the in order and you will find out that this C is in the right of this B. That means this C is in the right of this B, right. So if you see, we have covered all the 4 elements. So for this given in order and pre-order, this is the tree which is possible. Okay. Now let us suppose for some tree they are giving a post order and the in order, and let us see how to find the unique tree when they are giving a post order and in order. Okay. Assume that in order for this tree is D, B, E, A, F and C, and what is the post order for this tree? The post order will be D, E, B, F, C, A. Okay, so this is a post order and in order for a given tree. Now you have to draw a binary tree by using this post order and in order. Okay, so from this post order and in order, so what is the post order? Post order is left, right, root, and in order is left, root, right. Okay, that means this post order is always going to give you what is the root, and then you are going to use this in order to find what is the left subtree for this root and what is the right subtree for this root. Okay, so for this above post order we are having at the end we are having A, because we are having left, right, root, so in the end we are always going to get A. So in case of pre-order, assume that there is a pre-order, so pre-order is A, B, D, E, C, F. Okay, for this pre-order this initial element is going to give the root. Okay, but for this post order the last element is going to give us the root. Okay, so assume this is the last element which is going to give us the root, so the tree is A, which is the root, and then we have to identify what is in the left subtree for this tree and what is in the right subtree for this. For that, go to in order, and in case of in order you will see for this A the left is DBE and the right is FC. Okay, therefore in the left we are going to get DBE and in the right we are going to get FNC. Now we have to identify in this DBE what is the root. So to identify in this DBE what is the root, we have to go to the post order. Okay, and in this FC we have to identify what is the root, so for that we have to go to the post order again. So if you see here we are having this FC, right. In this FC in the rightmost side we are having C, so that means C is the root, and we have to identify now is F in the right part of this C or in the left part of this C, right. For that you have to go to in order and you see for this C this F is in the left, that means this F will be in the left subtree for this C. Okay, now for this DBE go to the post order and see what is the root. To see what is the root we have to see what is the rightmost element. Here the rightmost element is B, therefore B is the root here. Now we have to identify what is in the left subtree and what is in the right subtree. Okay, for that we have to see this in order, that means in B the left is D and the right is E, so we are going to get D and E. So this is the given tree for this above post order and in order. Okay, so this way you can easily find out what is the post order or what is the unique tree for a given post order and a in order. Now assume that they are giving you in order and the post order, and you have to identify what is the tree for this. Okay, let us suppose this is the in order. In order is 4, 2, 5, 1, 6, 3 and 7, and you are having a post order. So post order is that is left, right, root. So the post order is 4, 5, 2, 6, 7, 3 and 1. So this is the post order. Now you have to create a tree from this. Okay, so this is the in order. So in order means it is left, root, right, and the post order is left, right, root. Okay, so in the post order, in the end you are going to get the root element. Here in the end we are having 1, so 1 must be the root element. So for this one, we'll go to in order and we'll see what is the left side of this and what is the right side of this. So for this one, in the left we are having 4, 2, 5, and the right we are having 6, 3, 7. Therefore here in the left we are having 4, 2, 5, and the right we are having 6, 3, 7. Okay, now in this 4, 2, 5 and 6, 3, 7, we have to identify what is the root. Okay, so if you go to the post order, in the post order we are having these clusters which is 4, 5, 2 and 6, 7, 3. Now in the 6, 7, 3 you will see what is the element which is in the rightmost part, and the element is 3. Therefore this 3 is the root. Now if 3 is the root, we have to identify what is the left subtree and what is the right subtree. So in the left subtree it is containing 6, because I can see that from the in order. In the right subtree it is containing 7. Therefore 6 is in the left and 7 is in the right. Okay, now in this 4, 2, 5 you can see in the post order this 2 is in the rightmost part. That means 2 is in the root. So if 2 is the root, then you can see what is the left subtree for left part for this and what is the right part for this. So in the left part we are going to get 4, in the right part we are going to get 5. Okay, so that means this is the given tree. Right, now assume that for the same tree they have given some pre-order and in order, and then you have to identify what is the tree. Right, so they are giving you a pre-order for this tree. So what is the pre-order? Pre-order is root, left and right, and the in order is left, root, right. Now for this tree the root is 1, and the left is 2, and then it's going to print 4, 5, and then it's going to give us 3, 6 and 7. And what is the in order? In order is 4, 2, 5, 1, 6, 3 and 7. Now let us see if we can get a unique tree from this in order and the pre-order. So if you see this pre-order, in the leftmost part we are having the root, and the in order in the middle part we are having the root. So it is in the leftmost part, that is this leftmost part is going to give us what is the root. So the leftmost part is 1, so 1 is the root. Now if you see this in order, then this is the left part of this and this is the right part of this. So this left part is going to tell what is the element which are in the left subtree, and this right part is going to tell what is the element in the right subtree. So in the left subtree we are having 4, 2, 5, in the right subtree we are having 6, 3, 7. That means this 4 to 5, in this 4 to 5 we have to identify what is the root. So how to identify what is the root? We will go to the pre-order. So in this pre-order, what is the element in the leftmost part? The element is 2. That means 2 is the root. Now we have to identify what is the left subtree for this and what is the right subtree for this. So in the in order, in the left part we are having 4 and the right part we are having 5. That means for this 2, this is the left subtree and this is the right subtree. Okay. Now in the 6, 3, 7, you'll see you have to identify what is the root. For that, go to the pre-order and see what is in the leftmost part. In the leftmost part is 3, therefore left is the root. Now from the in order we can find out what is the left subtree and what is the right subtree. So here the left subtree is 6 and the right subtree is containing 7. Okay, so you can see we got the same tree if we have a pre-order and an in order, right? So by using a pre-order and a post order, we cannot identify a unique tree. Why? Because let us suppose we are having this above data. So the pre-order for this tree is 1, 2, 4, 5, 3, 6, 7, and the post order is 4, 5, 2, 6, 7 and 3. Right? Now in both these cases you will see in the left here in the left part and here in the right part we are only going to get what is the root, but we will not get what is the element in the left subtree of this root and what are the elements in the right subtree of this root. Okay, so this is going to create a problem when we are going to give a unique tree for using this pre-order and the post-order. Okay, if they are giving a pre-order and a post-order, it may be possible that these pre-order and the post-order having multiple trees. Okay,